AI systems can fail in ways we never anticipated, sometimes spectacularly. Even with extensive testing, they often behave unpredictably once deployed in the real world. The difference between AI systems that improve over time and those that spiral into liability often comes down to one factor: whether there's a structured approach to continuous learning. If I were starting an AI implementation today, I'd prioritize building robust feedback systems from day one. These systems serve two essential purposes. First, helping development teams improve their practices, and also tracking how AI systems behave in real world scenarios. Without both, there's a serious risk that the AI, while technically functioning, starts causing harm, becoming ineffective, or drifting away from the needs of its users. This is where the 12th Agile principle becomes especially relevant. At regular intervals, the team reflects on how to become more effective, then tunes and adjusts its behavior accordingly. While originally focused on human teams, the principle applies just as well to the AI systems that we're building because the feedback loop doesn't end at deployment. In many ways, that's where it starts for AI systems. Let's start with the development team. For AI, retrospectives go beyond the usual agile rhythm of reviewing team dynamics and task execution. These need to explicitly surface ethical concerns, identify biases, and consider unintended consequences. And that can't happen in isolation. These retrospectives work best when they include voices beyond the immediate team. So be sure to include ethics advisors, domain experts, even community representatives that are affected by the system's behavior. During these reflections, the team isn't just looking at iteration execution metrics or the performance of the AI system itself through incident rates data, for example. They're asking deeper questions like who might be harmed by the system or what assumptions are we building into this model? Those questions only gain traction when team members feel psychologically safe enough to voice concern without being seen as obstacles or holding back progress. Now, let's look at the other side of the feedback cycle: how the AI behaves once it's live. Unlike traditional software, many AI systems evolve post deployment. They adapt in response to new data, and that adaptability can introduce risk. How do we know they're learning the right things? And how do we catch drift early before it causes damage? There's growing and justified concern that AI could become an eye of Sauron, constantly watching, undermining privacy, and exerting undue control. That's why it's critical to balance the need for data to improve AI systems with the deep respect for user consent and boundaries. Responsible feedback doesn't require invasive data collection. We can design user centric systems that invite insights rather than forcibly extracting them. For example, we can create clear feedback channels where users can share experiences directly. We can do random sampling of AI outputs for review. We can do aggregated, anonymized interaction patterns that reveal where systems are falling short. And we can establish feedback communities where users compare experiences and report inconsistencies. These mechanisms are especially critical for AI agents. While increasingly popular, these systems are also amongst the most inconsistent. In complex real world tasks, advanced AI agents can fail between 20% to 40% of the time. For instance, one study detailed in a New Yorker article on robotics reported that a robot trained via reinforcement learning to fit a block into a socket succeeded only 60% of the time, implying about 40% of failure. This specific outcome, observed under conditions requiring precise manipulation and adaptation to variable inputs, reinforces the notion that even state of the art AI agents face significant challenges that necessitate robust, continuous feedback systems to correct errors in real world applications. That's why continuous learning isn't a luxury, it's a safeguard. Feedback systems surface issues early when they're easier to fix and help maintain alignment between what an AI system is doing and what it's meant to do. So, how do you start? Begin small, pick a tightly scoped problem, define what success looks like, and build lightweight feedback mechanisms into both the development and operational sides of the work. Use that experience to refine your approach as you scale. This allows both your AI capabilities and your learning systems to mature together safely. If the idea of building these systems feels overwhelming, that's okay. You don't need to get everything right from the start. You just need to get started. Begin with basic retrospectives that deliberately include ethical and safety considerations. For user feedback, start with something simple and transparent. Offer users a clear way to report unexpected behavior and make sure that feedback is visible, valued, and used. Ultimately, the AI leaders of the future won't be defined by how advanced their models are or how much data they collect. They'll be defined by how fast they learn and deliver what customers truly need. The ability to catch issues early, adapt quickly, and very stay aligned with values, that's what creates sustainable success. So as you think about your own AI journey, ask yourself, how will you know if your systems are truly working? What signs will alert you to drift or harm? How will you gather meaningful insights from the people using them without compromising their trust? And most importantly, are you open to receiving this feedback and taking action, even if it means deviating from your original vision for the product or service? Your answers to those questions might end up being more important than any model you deploy. Let us know in your thoughts and your comments. And if you'd like to learn more about the value of giving and receiving honest, useful feedback, like one of these, then I'll be happy to tell you all about it.